Well, hi, good morning. Thank you so much for joining me in my shop here on September 27th. And the sun is shining outside again today. Just wonderful weather. Okay, so what's left in this radio? Two unreliable capacitors. One you can see right here, and the other one is hidden a little bit in a metal shell up here. So I think we'll start by looking on the schematic, take a look at what these two capacitors are there for. One in the metal shell and one is not, both located right near the volume control. Let's take a look. Okay, so here's the layout diagram, and here's the volume control on the back apron of the radio, front apron actually. This is the volume control, the capacitor that's inside the metal shell. And then here's the other one. So let's start with this one here. So one side's going to ground, the other side is connected here ahead of a moderately large resistor, 40,000 ohm resistor. Resistor is connected to here, and this is connected through a small capacitor to the input side of the volume control. The other side of the volume control, if you follow this wire, it connects to the chassis. So this is the grounded side of the volume control, this is the input side, and this is the output that we select with the control. It will show up here. So could be loud, could be quiet on this control. This goes through a shielded wire through a hole in the chassis up above to a cap, a grid cap on top of this tube here. So the output, the audio output of the volume control is fed to the grid of this first audio amplifier, 6Q7. Okay, now I said we'd start with this, but I think we're going to end up talking about this one here. So this ties back to the second IF transformer. And out of here is coming the rectified output of this IF transformer secondary. The rectified output has recoverable audio in it, and that's what's happening. The audio is fed to the start of the top of the volume control, input side of the volume control. This back here, this is a volume or tone compensating situation. It's very common in these radios, where it was learned early on that at low volumes, we don't hear bass very well. Bass kind of drops out at low volumes. Our hearing is not linear volume-wise. So if you're listening to music at a low volume, you won't hear as much bass as is actually there, or you would hear, relatively speaking, if it were at higher volume. So to compensate for that, they fancied up the volume control in such a way that when you turn the volume down, the bass is increased. Now that could be happening because the treble is being cut away at low volumes. Seems kind of backwards to me, but that could be what's happening. So if we see how this is connected, capacitor to the input, so, and then a resistor, and I'm not going to try to explain exactly how this works because I can't. Some of the high frequencies traveling here are going to be shunted to ground. Now, how did they get here? You have to go all the way over here and look at this other control. What is happening here? This is the tone control mounted on the front side of the front apron here, so that's why it's dotted. And then here's another one sitting here. This has confused me since this radio is showing up. Speech, music, and power switch. Okay, so the power switch is on the back here. The speech and music thing has to do with the potentiometer inside here. It's connected up this way, just as a variable resistor. So my guess about how this operates is if you're listening to someone talk, you would knock the bass out of their voice using this control. I think. And that would be called the speech setting. You turn this control another way and the bass will be more evident, and that would be better for music, and that becomes the music control. How that really differs from a tone control exactly, I don't know. But controlling tone was of interest to the engineers who designed these radios. Getting proper, attractive, consistent tone coming out of the speaker is what this is all about to a large degree. So often engineers get carried away in these areas of tone control. And you find, I found that just about every radio is done a little bit differently. So it's a little tricky to know exactly what is going on in each radio in terms of tone control. But this I want to call it a tap. This tap here is very common though in the volume controls. Okay, so in the modern stereos we have a switch called loudness, and you flip on the loudness switch when the volume is low, and it does the same thing. It either boost up the bass or knock down the treble a little bit to give you a more pleasant presentation of the sound you're listening to, even though in fact it's being, I wouldn't want to say distorted, but it's being altered. It's not normal anymore. Anyway, enough talk about that. So what happens if these capacitors are bad? So if this guy's capacitance has gone down, it's a fairly large one, a 0.01, some signal wouldn't get through here and the volume would be reduced on the radio. Probably it would have to be an awfully bad capacitor to really knock it down. That's what would happen here. I guess we could think about it. What if this were totally open? Well, there'd be no sound coming out of the radio. What if it were shorted right out? I don't know. We'd have to try it and see, and I'm not about to do that. Replacing this, I think I can probably pull the capacitor out of this bracket and just slide a new one in there, and that'll be just fine. Now this capacitor, if this one's acting up, we know this is involved with the tone control. We know its job is to somehow make a bass boosted situation or a treble cut situation. Looking at the way it's arranged, higher frequencies are going to travel through this easier, and where are they going? They're going to ground. So this is a treble cut arrangement. Now if this wasn't working, then this tone control thing would, over here, would probably have little to no effect. If this were shorted or otherwise, we would have, I don't know, bad tone. We'd have bad tone. I'll leave it at that. So impacting the overall operation of the radio only minimally, I believe. So let's replace them. We'll do let's fiddle with this tone situation and the tone controls a little bit. Listen to the radio, fiddle with it, and then we can replace this one and see if it really makes any difference or not. 0.007. Okay, that'll be the plan. Okay, so what I'm going to try to do here is feed a controlled signal into the radio, tune it in, and then in that signal have a audio signal that's varying in pitch, and hopefully listening to that we can somehow sort out what these tone controls are doing. Probably not the best way to do it. Probably some white noise would probably be a better approach, but I don't have a white noise maker in here exactly. Well, I guess I do. Every FM radio between stations produces white noise, but let's try this anyway. So I've got the signal generator running at 1500, so let's turn on the radio, see what we get here. Just a quick safety check. Yep, everything's good. Give it a moment. So this is a sweep generator, so I can give it a low frequency and a high frequency, and it will sweep up between it. And it sweep slowly or sweep quickly. Right now it's going to sweep, I think it's set for a second, but I'm not sure that this control is actually correct. But take about a second to go from the low to the high. The low is 75 hertz. That's pretty low. And the high is not very high. The high, I want the high a lot higher. Let's say 5, 6, 7, right up to the top. 11 kilohertz. Okay, so that's probably high enough to start hearing some effect here. Right? And again, I don't know how well this is going to work. The output of this is becoming the modulation input for this signal generator. That's what this cable is doing right here. We'll see how this works. Okay, radio should be warmed up. You can hear a little bit on full volume because I've got this connected. It's like putting a short circuit on the antenna. We need to tune the radio to 1500 or tune the signal generator to where the radio is. Let's move the radio a bit here. Wow, it's very hard to tune with the knobs not on it. Okay, so that's around 64. Let's go a little higher. There we are. Let's try it right in here. That's around 700. Okay, so I'll tune this to 700 now. We'll see what happens. I can't get the 700 here. Here we are, 700. Okay, listening. So this is an interesting test for another reason. I'm feeding a known signal level into the radio and I'm hearing what the result is. I know from experience, a very sensitive radio would pick this level up fairly well. This one, you got to turn the radio right up. Let's go up 10 times stronger. Now, we want to set this to external. And we want to raise the level on this until we can hear it. And raise the level here. And I don't hear a thing. Oh, this isn't sweeping. Here we go. Whoa, 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 whoa. Okay, certainly heard that. Certainly heard that. Let's just, I didn't have it sweeping, so let's reduce the output here. Get it sweeping. Okay, should try this on full. Slow it down more. But the top 15% I can't hear anything. There. Until it starts again. Okay, now some tone controlling here. That's more trouble. Definitely hear it higher. I could definitely hear that higher. This is a terrible way to do this. Okay, what's that other control do? That's one extreme there. Doesn't sound like it does. It doesn't seem to do a thing. I don't think I heard any change at all. Okay, let's do this a little differently. We'll stop the sweep here. We're now putting out a 77. I don't know if you can read the numbers here. 77 hertz. That's really low. Not only is it going to be difficult to hear it for about a dozen reasons. Not only. Don't even finish the sentence here. How am I ever going to hear that? Let's raise this up. To about the lowest I can hear. shaking the bench a bit. It's 100 hertz now. Okay, let's try that. What happens to 100 hertz? Tone control. So you see it's just a treble cut. The bass remains the same. And this control, everything is having no effect. Okay, maybe I misinterpreted it. Let's go to the high end here. So that's 11,000 hertz. We can't even hear it. I'll bring it down a bit. Okay, make sure the tones are high. Still can't hear it. Let's just give it a bit more. We gotta go down lower. Wow. What's happening? I can't hear anything at all. Let's keep going lower. So this says 5 kilohertz here, 5,000 hertz. 6,000, you can hardly hear it. 7,000 gone. So let's put it on the 6,000 setting. What happens? It's just gone. You might be having a very hard time hearing this. There's a lot of room effects here. I'm moving my head around. That high pitched tone is coming and going because of the room effects. Okay, what about this one now? Pretty easy to conclude this control is just doing absolutely nothing to the sound. Speech and music. How sure am I that it's not doing a thing? Pretty sure at this point. Could it be because of this capacitor? Could be. Could it be because somebody monkeyed with this volume control? Could easily be. Could it be this control is actually... Whoops, that part's connected. This part's not even connected. I can't really see what's going on. Let's start there. Let's start right there. What's going on? Who's done what? How do I know this volume control's been changed? There's a very, very good chance of it because there's one of these tone compensating taps here and nothing connected to it. Nothing has ever been connected to it. They're not going to put this in the factory. They're not going to put in a volume control that has a terminal on it that they don't use. So pretty sure this is a replacement. Probably the target was to replace the on-off switch. That's probably what the problem was. So the tone compensating, all that kind of stuff may have been forsaken, ignored, accidentally messed up. A little hard to get up in here, but let's see what we can do. I might need a mirror in the end. Okay, let's go to that camera that I'm fiddling with. Okay, let's try this. I think this will work a little bit better. The resistor going through a hole there. So there's one connection of 3 and nothing soldered to it. That's exactly what it's supposed to be, I think. And you can see the other, you see a wire coming over. It's coming out of this shielded cable. The shield is grounded. They have a shielded cable coming. Looks like it's attaching to the center post, and then this resistor coming through a hole. That's a little odd. A resistor, is it coming through a hole, or is it just grounded there and I can't see it? What's going on there? Black gunk in the hole. The resistor appears to be soldered to the upper part of the deck here. Let's just look around the other side here. Where's that? There? Is that the hole? Where's the hole? Let me shine a light through the hole. Okay, so the hole we're interested in is lit up. Oh, there's nothing coming through there. Oh, that's not the hole. That's... Where's the hole? Where's... Oh. Just hang on a second here. It's just going to take me a second to make sure I've got this hole in view. I think that's the hole. Maybe if I put the light up here, I'll be better off. Well, there's no hole there. Where's the hole? It should be right here. Is it hidden from view? It's hidden behind that? What is that? That looks like the side of the big transformer. That's what that is. I don't get it. How did that go wrong? Okay, I'm going to shove something through the hole here, and then we'll be able to identify it. So we'll put this through the hole. Try anyway. Okay, where's that yellow piece coming out? There it is. Well, that's the hole. Is that the wire coming around? What the heck? What are they doing here? Let's check out a couple of diagrams at this point, because I don't know what I'm looking at here. Okay, so if we're looking here, and we're not looking here. We're looking way over here. We're looking for a hole that something goes through. Well, here's a hole, but that's not it. Here's another hole, but there's. Where's the resistor? This is the resistor. The resistor is shown going to ground. That's definitely the resistor going to ground. Where the shield is connected from the shielded wire, which is coming over to the center. Look for where the shield is connected. Find the ground terminal. Look at this resistor again. What's it doing? Okay. Get back around to this side. Now, what did I just say? Look for the shield of look for the shield of the wire coming excuse me, coming over here. This is not going to work out. I gotta tilt this radio differently, because so I think I can stand this radio right up on its head here. Get a view of this. Buying this control here. Oh, I get a much better view of it. Okay. What is going on in there? So what I can see right away is a big blob of solder here I couldn't see before. A little too close for my camera. Okay, good enough. So here it is, soldered right to the chassis. Here's the shield, soldered right to the chassis nearby. There's the lead wire, or the signal wire, coming in there, going to the center pin. So it looks like it's connected. Looks like it's connected appropriately. And so where's the wire that comes all the way over here? This is the wire coming over. Yep, shield, green lead, resistor to ground. Is that all there was? I thought there was a little more to it. Let's take a look. Shield and resistor grounded. Lead coming over. Here's the lead going to center. That's it. So it's connected exactly the way it should be. Is this 15,000 ohm resistor? Is it really 15,000 ohms? Well, we'll put the ohm meter on it and find out. So nothing going on at this end that's unusual. So the control doesn't seem to do anything. We'll check that resistor next. Might as well check them both. We'll check that one, and then we can check this one. 40,000. So it was you forgot already. 15 and 40. 15 and 40. 15 and 40. Now these are in the circuit, so you might not get what we would expect. 15 here. 26. That's quite different than 15. That's double. I can see the body, end, and dot in that resistor. So it's brown, green, and then the orange. So it's 15. It's supposed to be 15. And it's double. Now it's in the circuit, so that can affect the reading, but it can only make the reading less. So if the reading is more, the resistor is, this could even be open, and I could be reading through this control or something. Let me change the position of the control. Same reading, basically same reading. Well, that's the first resistor I've tested in this radio, and yuck. It's not really what I wanted to see, because what's true of one is probably true of all. Oh, we don't want to do that. We don't want to think that. Now there's another resistor in the circuit way over yonder, and I believe it would be this one here. This is supposed to be 40. Now I can't see. I can't see. Can I see now? Can't see a thing. Getting blind here. Time for new glasses. That's what it really is. For some new glasses. Very tricky to get on the across this resistor. $40. That's exactly what it's supposed to be. So you have one up here which is double its normal value. Double its intended value. Double the value that's written right on it too. So no question about that resistor being high. Well, we could replace that. We'll keep that in mind, and we'll replace the capacitor, see if the tone control starts giving an operation or not. Now that we sort of have a feel for it, let's cut it out and put it on the tester. Let's find my cutters. Hey. Who took the cutters? Here they are. it's a little short guy. 0.007. 400 volt. I don't think you need 400 volts there, do you? But you know, they're building anything, you want to keep your number of parts in the warehouse to a minimum. So they might just say all capacitors have to be rated to 400 volts or higher or something like that. And that's how you end up with higher rated capacitors than necessary. As a guess. Okay, 50 volts, what do you do? Well, it won't even open. So, you know, and compared to many other radios that I've had come through here, this one is a little worse than many in terms of these capacitors being bad. Okay, so I'm going to put in another 0.007, make sure it's exactly the right size. And I don't want to fool with the size here, it'll affect the tone. And we'll see what happens. 0.007. Okay, got the 0.007 capacitor in there now. Let's find out. I'm going to leave the radio upside down. I think it's harmless. Upside down. Some of the very old radios from the early or mid 1920s, the tubes really have to be stood vertically upwards. It can't be turned on their sides and operated because the filament is long inside them and very poorly supported, and it's designed to be supported this way. If you tip it like this, the filament can droop and blow the tube. Not so with these, and right upside down probably wouldn't matter. It's on its side that would cause a problem. Okay, so let's give it the full deal. Now, what exactly are we doing here? So first of all, I hear, maybe the volume's way up. Yeah. So there's a kind of hum in there that I don't like hearing. That's the regular tone. So this controller, it's possible this radio's better off without this control working. It's having an effect. But I suspect a long wire coming over here. The long wire is maybe giving trouble. The high resistor here could be introducing this hard to catch hum. You know, if you do a lot of this work, you can hear it. It's right there. I don't think that was there before. Was that there before? Don't think so. Okay, tone experiments. Are we tuned in here? Wow, this just doesn't... So we're sending a 6,000 hertz signal into this radio. That's a little high, eh? Okay, that's 4,000 hertz. That works nice. Let's go lower. Can't hear anything happening. Let's go lower yet. Too low. See, oh, the tone doesn't change because it's low enough now. It's below the treble cut. Well, I don't know what to make of this. I would leave it the way it is now, except it's got this humming thing here. Let's get this off here. Turn this up. Where'd the humming thing go? So what exactly is happening with this control either? I don't know. When you get to the end, is this control so dirty that the slider's not making any contact? Except right at the end. Right at the end, it's bumping into something. You know, that's possible. I had seen it. I've seen a radio completely dead until the volume control was cleaned. Let's spray some junk in it here. Anything coming out of this? Yeah. Voice and music. Well, maybe we gotta have voice on here or music on here to hear the difference. But I'm not getting any good feelings out of it. We'll change that resistor, but not. You know what I can do? I can temporarily do something. Don't know if it's a good idea though, because it involves hooking up some long wires here. That resistor was 1500. So I've got a decade box here. I'm going to try to clip onto it, but maybe it's just going to make a lot of humming noise here. Let's give it a try. Got your fingers going right in by the power cord here and everything. Okay, so now I have this box paralleled with the resistor that's in there. The resistor has gone high. I can't remember, it was double. So if I dial this up to around the 1500 mark here, and I don't know what's, I don't know how valid the resistors are in here or anything. Let's see what happens. Put this midway. What do I expect will happen? I honestly don't know. I think the way I'm doing this, if something's happening, I wouldn't even be aware of it. Let's try this. Volume down. I'm going to disconnect the signal generator, hoping for a nice hiss in the radio. Let's see what we get. What do we get? There's that hum. Okay, hum maxed. See that? Ooh, fades out here. Okay, let's just bring it up to where it's just starting. that's 1,000 now. We're below, well below the. Oh, it is making a difference. So I'll turn it way up. You can hear a higher frequency buzzing. That's really low. No difference here. No difference there. But when you go right to the end, just before the end, ooh. What's it all mean? More buzzing, less buzzing. That's roughly the right resistance, roughly. What I'm trying to figure out is that resistor's gone high and that's causing this buzzing. That's terrible. And reduce the resistor down to next to nothing, and it's not going away. Okay. Not sure what to think. Fiddling around here, getting nowhere. Trying to solve a problem is probably not a problem. Turn the volume down to normal listening range. You don't hear any of it. Of course, you're going to turn the volume right up. Amplifier's going to amplify every little piece of junk there. Well, I don't know what else I can do about this anyway. So we're going to leave it the way it is now. And yeah, well, I do know what I could do. I could change that resistor, but we're not going to do that. I'm going to go after this other capacitor here. Let's turn this off before I forget. Now this other capacitor. It's in this shell, and the metal shell has been, somebody's managed to solder it down right onto the chassis. How did they do that? But they did. So what I'm hoping is I can extract the capacitor that's inside here and just slide another one in. So to do that, I need to cut it here and slide it out. Once again, I've lost my cutters. Here they are. I'm going to cut it right here. I've done this before and it has worked. That did not come loose at all. You can end up ripping the whole capacitor apart. It looks really tight in there. Maybe I can bend this open a bit. It's probably just a metal, metal sleeve with a seam somewhere on it. They soldered the seam closed. Oh, just bent it. Yeah, I'm just going to rip the end out of the capacitor. We can't get another one into here. It's not the end of the world. I'm pretty sure. What else could I do to loosen it off, to get it to come out? The only thing would be to bend this open. And I can't even see the split on it. Let's put the close-up camera, see if I can see a split. looks like it's overlapped. I don't think there's any split I can pry open, but you see there's a little gap in there, and there's quite a gap on this side, I think. Well, no, not quite a gap. I can stick something down in there and try to work the capacitor free from the shell. Stick a little tiny screwdriver down there. There's not going to be any room to jam anything in there. What could be holding this in place? Just sticky friction. I think just sticky friction. I can shove it through this way. Look at that. She's coming out. Okay, let's cut this here. It's a push-pull situation. It requires a push and a pull. It's got nothing written on it. Maybe it did at one time, but it doesn't anymore. But it's on the schematic. Let's just take a look in that shell and see if there was a split. And, no, I would say there's nothing. There's nowhere to kind of pry it open. Okay. Now, what about sticking it in? Just grabbing any old capacitor here to see if it'll fit, which I think it will. Yeah, see, it's just going to go in there. Good. Doesn't have to be snug or anything like that. Great. I will put the new capacitor in there, and we will listen to the radio one more time. Okay, new capacitor's in. Let's give this guy a test. And anybody want to take a guess? My guess would be it'll be just like all the rest. Won't even pass 50 volts. Let's see. Am I a winner? I'm a winner. Yeah. Bad. So typically in these old radios, I find at 50 volts you get a partial opening, and at 150 it may not open, or it may open just a little wee bit. These ones, 50 volts, no good. It's no good. Okay, time to operate the radio. I'm going to stop for a moment here. Maybe go drink some coffee, and then we'll operate the radio and double check everything. Yeah, lots of strange things happen in this shop. So I was just going to turn the radio over, right side up. And as I did, this came out of it. This is water. Where the heck did water come out of this? How could this be? Where else could water come from in here? Out of my ceiling? No. And it's a lot of water. But I didn't clean anything with water. Certainly not that volume. Nothing in here. I don't get it at all. What would be dripping water right out in here? What could possibly have water in it? It's dripping here now. Holy smokes. Let's take a look. I can't believe what's happening here. What is happening here? That's the water. It's not oil. It's not the WD-40 at all. It's just water. And it came out somewhere. Is there anything wet? Do I see anything? Like, could it have come out of one of those? How would that be? I don't understand. Yeah, I don't understand. I don't get it. What else have I got in here that's got water in it? This is crazy. This is just crazy looking for water in the back of a radio. Some other thing must have happened. Some other thing. Some other thing. I don't know. Okay, let's tip it down again and see if more drips out. This time I'll look more closely. Too bad I didn't really recognize where it fell from. And some more come out. Nothing on top. Wow. Okay, that's the strangest thing. I have just no way to account for water on my bench. What a weird thing. We'll have to just go on the basis that it doesn't mean anything, that it's... If I knew what it was, I would be unconcerned. So we're going to try this on the antenna here. Just on my outdoor antenna. Make sure we get the right one here. I'm pretty sure it's this. It'd be better if I clipped it inside. Okay, antenna connected. Okay, I'm going to turn off the signal generator here. Just get them out of the picture. Turn off my soldering iron too. For the big moment here. This really isn't a big moment. This is not a big moment. This is just a moment. Okay, volume is down. Multiple tone controls are here. Here we go. Lots of volume. To lubricate the tuning here. It's really tight. Okay, we hear the station. Tone controls. The real one. Huge range. The other thing. You really got me. Okay, we don't know what that is. That's going to drive me nuts. Very good. So where we're at now is ready to check the tube voltages, then do a preliminary alignment, a quick alignment, see what the situation is at that point. Perhaps test the tubes, but if the radio is working well, there's no reason to test the tubes. and we'd be done. So a couple more days on this guy, I think. Anyway, very good. Okay, 2 capacitors. Made a big deal out of it. See you on the next video. Bye.